Hi students, in last class we discussed about free fall and equations of motion. In this class we will discuss the problems based on equations of motion and free fall. Before going to solve the problems, we will discuss time of ascent, time of descent and maximum height. Time of ascent. Time of ascent is represented by TA. What is meant by time of ascent? Time taken by a body to reach maximum height is called time of ascent. When we throw a body with certain velocity, it will take certain time to reach maximum height. Time taken by a body to reach maximum height is called time of ascent. Here, consider an object is thrown into air with certain velocity. Here, u is the initial velocity. When it reaches maximum height, its velocity will become 0. When we throw a body with certain velocity, its velocity slowly decreasing with height. Finally, its velocity becomes 0. So, v is equal to the 0. H is the height, and here the object is moving opposite to the direction of acceleration due to gravity. That's why g is negative. A is equal minus g. By substituting these values in this equation, v is equal u plus at. v is 0. U is u, that is initial velocity. G is negative and T is TA. In place of T we are writing TA, that represent time of ascent. So minus GTA will become plus when we move towards left side. So GTA is equal u. Then TA is equal u by g. TA is equal u by g. Formula for the time of ascent is u by g. Remember this formula, this is very important. Formula for time of ascent is equal u by g. Next, we will discuss about time of descent. Time taken by a freely falling body to reach the ground is called time of descent. When a body is falling freely, it will take certain time to reach the ground. Time taken by a freely falling body to reach the ground is called time of descent. Time of descent is represented by TD. Here remember, time of descent equal to time of ascent. This is very important. Time of descent is equal to the time of descent. Whatever the time it will take to reach maximum height, the same time it will take to reach the ground. So what is the formula for time of descent? Time of descent also given by u by g. Time of ascent is equal to u by g. Time of descent also equal to the u by g. Maximum height. When we throw an object with certain velocity, it will reach certain height. Its velocity slowly decreasing. At certain height, its velocity become 0. That height where its velocity will become 0 is called maximum height. Maximum height is the height at which the velocity of the vertically thrown object will become 0. Here the object is thrown with certain velocity, that is u is the initial velocity. Already we discussed at maximum height its final velocity will become 0. Remember, at maximum height final velocity will become 0. Here height is the h and here the object is moving opposite to the direction of free fall acceleration. That's why A is equal minus G. So by substituting these values in third equation, V square minus U square is equal to AS. By substituting these values in V square minus U square is equal to AS. V is 0, 0 square minus U is U, U square is equal 2 into A is minus G, S is the H. So what you will get? Minus U square is equal minus 2GH. Minus minus will be cancelled. H is equal U square by 2G. H is equal U square by 2G. This is the formula for maximum height. Time of flight. It is represented by capital T. Time of flight is represented by capital T. It is the time for which body remains in air. Time of flight is the time for which body remains in air. When we throw stone into air, it will travels to maximum height. Again, it returns back. It will reaches the ground. The total time for which body remains in air is called time of flight. Time of flight is equal to the sum of time of ascent and time of descent. Time of flight is equal to the sum of time of ascent and time of descent. So, time of flight T is equal, time of ascent is U by G. Time of descent is U by G. U by G plus U by G is equal to the 2U by G. Time of flight T is equal to U by G. Formula for time of flight is equal to U by G. Remember all these formulas. These are very important while you are solving the problems. Now we will see one problem. Find the time taken by the body projected vertically up with a speed of U to return back to the ground. Here an object is projected vertically up with initial speed U. Then it will travel towards the maximum height. At maximum height, its speed will become 0 and again it returns back. So we have to find the time taken to complete journey. Here the object is thrown upwards, it will travel to maximum height and again it will return to the ground. We have to calculate the time taken for whole journey. That is nothing but time of flight. So we will see the solution. Let us take the equation S is equal ut plus half at square. We are taking second equation, that is S is equal ut plus half at square. For entire motion, S is equal 0. For whole journey, displacement is equal 0. The object is starting from the earth surface. It reaches the maximum height, again reaches the earth surface. So for entire journey, displacement is equal to the 0. When an object starts from certain point, after the completion of the journey, if it returns to the same point, then displacement is equal to the 0. So here displacement is equal to the 0. Initially, the object is thrown upwards with a speed of U. U is the initial speed and V is the final speed when it reaches the maximum height. H is the height and acceleration is minus G. So by substituting these values in S is equal ut plus half at square. So S is the 0, ut minus A is equal to the minus G. So minus of gt square. If you transport minus of gt square towards left side, then what you will get? Of gt square is equal ut. Of gt square is equal ut. Here we can cancel t from right side and square, t square. So what is the remaining? Of gt is equal u. Of gt is equal u. Then t is equal to u by g. T is equal to u by g. Already we discussed time of flight is given by t is equal to u by g. We will see another problem. Now we will see another problem. A ball is projected vertically up with a speed of 50 meters per second. A ball is projected vertically up with initial speed 50 meters per second. Find the maximum height. We have to find the maximum height, the time to reach the maximum height, and also we have to find the time to reach the maximum height. The time to reach the maximum height is nothing but time of ascent. We have to find time of ascent and the speed at the maximum height. And also we have to find speed at the maximum height. Here g value is 10 meters per second square is given. G value is given, that is 10 meters per second square. So what are the given data? Speed of ball is given. Initial speed of the ball is 50 meters per second. Then maximum height. What is the formula for maximum height? Maximum height h is equal u square by 2g. So by substituting the values, we will get u is the 50 square, 2 into g is the 10. Fifty square is equal 50 into 50 and 2 into 10. 1 0 from 50 and 1 0 from 10. We can cancel that. So what is remaining? 50 into 5. 250 by 2. 250 by 2. So h is equal 125 meters. 250 by 2 is equal 125 meters. That is the maximum height. Time to reach maximum height. We have to find time to reach maximum height. Time to reach maximum height is nothing but time of ascent. That is equal TA is equal u by g. Time of ascent formula TA is equal u by g. By substituting the values, u is 50 and g is 10. 0 0 will be cancelled. Then time of ascent is equal 5 seconds. Time of ascent is equal 5 seconds. Speed at maximum height. Already we discussed when we thrown any object to certain height. As it goes high, its velocity slowly decreases and finally its velocity becomes 0. At maximum height, its velocity becomes 0. So speed at maximum height is 0 meter per second. Now we will see another problem. A stone is fall freely from 20 meters height. Find the velocity to reach the ground. A stone is falling freely from 20 meters height. Height is given, that is 20 meters. Find the velocity to reach the ground. We have to find the velocity when it reaches the ground. Here g value is given. G value is 10 meter per second square. So height 20 meters is given. G value 10 meter per second square is given. Here a stone is falling freely from 20 meters height. then u value is 0. When it is falling freely, initial velocity u value is 0. We have to find v value. Height is given, that is 20 meters, and g is positive. And the object is falling freely, g is positive. So by substituting in, v square is equal to 2gh. From v square minus u square is equal to as. Here u is 0. So we will get v square is equal to 2gh. So v square is equal to 2 into g value is 10 and h value is 20. So 2 into 10 is equal to 20. We can write v square is equal to 2 into 10, 20, 20 into 20. V square is equal 20 into 20. Then v is equal to under root 20 into 20. What we will get? V is equal 20 meter per second. Final velocity to reach the ground is 20 meter per second. Now we will see fourth problem. What is the speed of an apple dropped from a tree after 1.5 seconds? An apple is dropped from a tree. It is freely falling fruit. So we have to find the speed of the apple after 1.5 seconds. What distance will it cover during this time? And also we have to find the distance it will cover during 1.5 seconds. Take g is 10 meter per second square. G value is given, that is 10 meter per second square. Now we will see the solution. Time is given, that is 1.5 seconds. G value is given, that is 10 meter per second square. Here apple is falling freely. So u value is 0. We have to find the velocity after 1.5 seconds. A is plus g. So by substituting these values in first equation, v is equal u plus gt. V is equal, u is the 0. For a freely falling body, initial velocity is 0, g value is 10 and time t is 1.5 seconds. So 10 into 1.5 will become 15. V is equal 15 meter per second. Velocity after 1.5 seconds is 15 meter per second. Then distance covered. We have to find the distance covered during 1.5 seconds. So by using the formula v square minus u square is equal to as. Here u value is 0. For a freely falling body, u value is 0. A is plus g. S is h. So what if we will get? V square is equal to gh. V square is equal to gh. Already we know the value for v. Final velocity is 15. So 15 into 15 or 15 square is equal to 2 into g value is 10 into h. 15 square is equal to 225 by 2 into 10 is equal 20. 225 by 20. So h is equal 11.25 we will get. H is equal 11.25 meters. Now we will see last problem. Find the free fall acceleration of an object on the surface of the moon if the radius of the moon and its mass are 1740 kilometers and 7.4 into 10 power 22 kilograms respectively. Compare this value with free fall acceleration of a body on the surface of the earth. Here what are the given values? Radius of the moon is given, that is 1740 kilometers, and mass of the moon is given, that is 7.4 into 10 power 22 kilograms. We have to find the free fall acceleration of the moon, and then we have to compare the free fall acceleration of the moon with the free fall acceleration of the earth. So radius of the moon is given, that is 1740 kilometers. 1740 kilometers can be written as 1740 into 10 power 3 meters. Every value we have to keep in SI unit or CGS units. Mass of the moon is given, that is 7.4 into 10 power 22 kilograms. G value, universal gravitational constant, capital G is equal 6.67 into 10 power minus 11 Newton meter square per kilogram square. This is very important value. We have to remember capital G and small g values. Free fall acceleration on the moon. Already you know the formula for free fall acceleration. That is, free fall acceleration on the moon, Gm is equal capital Gm by r square. Capital G is the universal gravitational constant. M is the mass of the moon. R is the radius of the moon. By substituting the values in the formula, we will get Gm is equal, capital G is 6.67 into 10 power minus 11. And mass of the moon is 7.4 into 10 power 22. Radius of the moon is 1740 into 10 power 3. R square is there, that's why we are writing twice. 1740 into 10 power 3 into 1740 into 10 power 3. Here in numerator 10 power minus 11 is there and 10 power plus 22 is there. So it will become 10 power plus 11. And in denominator 10 power 3 will become 10 power 6. In 1740 10 is there. In another 1740 also 10 is there. So we can write 174 into 10 power 1. 174 into 10 power 1. So in denominator it will become 10 power 6, 10 power 1, 10 power 1. Total it will become 10 power 8. Gm is equal 6.67 into 7.4 into 10 power 22 into 10 power minus 11. That is equal 10 power 11 by 10 power 3 into 10 power 3 will become 10 power 6. 1740 we can write 174 into 10. So we are writing 174 into 174 into 10 power 1, 10 power 1 and 10 power 6. Total 10 power 8. That is equal to the Gm is equal 49,358 by 30,276. 174 whole square is equal 30,276. 6.67 into 7.4. We will get 49.358. 10 power 11 by 10 power 8 is there. So what is the remaining value? That is 10 power 3. So 49.358 into 10 power 3. That is equal 49,358. GM is equal 1.63 meter per second square. Free fall acceleration of the moon is nearly equal to 1.63 meter per second square. Now we have to compare the free fall acceleration of the moon with free fall acceleration of the earth. So GM by GE, free fall acceleration of the moon by free fall acceleration of the earth, is equal, free fall acceleration of the moon is 1.63 and free fall acceleration of the earth is 9.81 meter per second square. 1.63 by 9.81 is equal to the 1 by 6. GM is equal 1 by 6 GE. So what we can say? Free fall acceleration on the moon is 1 by 6th of that of the earth. Free fall acceleration of the moon is 1 by 6 of that of the earth. Similarly, weight also. Weight is nothing but gravitational force of the earth on the object is called weight. Weight of the object on the moon is 1 by 6th of the weight of the object on the earth. For example, your weight is 30 kilograms on the earth. Then your weight is 1 by 6 into 30, that is equal 5 kilograms on the moon. Free fall acceleration on the moon is 1 by 6th of that of the earth. Similarly, weight of the object on the moon is 1 by 6th of that of the earth. Students, all of you make notes, prepare well. We will continue in next class.